Okay, let's do some subtraction. Subtracting is the same thing as adding. If you have the same denominators, you can just add the numerators. If the denominators are not the same, then you're going to have to make them the same. And then once you have done all that, combined everything, then you will want to simplify, see if there are any common factors. All right, so on problem 26, we have the same denominator. So all I have to do now is just add the numerators. So my common denominator is x plus 7. My numerator becomes x minus 3. There's nothing else to do here. This is a prime factor. This is a prime factor. Nothing you can simplify. So there you go. Okay. Here, now there's a little twist here. If you want to do this, this becomes, you've got a common denominator of x plus 1, and you have 5x minus 8, and you have to subtract this entire polynomial. Whoops, sorry. So that's the same thing as either just taking the opposite of everything or distributing a negative 1. So this becomes 5x minus 8 minus 3x minus 5 all over x plus 1. When I combine my like terms, I have 2x, and I have 5x minus 3x. Negative 8 minus 5 gives me negative 13 divided by x plus 1. Now, in terms of simplifying, this is prime. There's no GCF. This is prime. So this is your final answer. But you will not check to simplify until after you have combined everything. Okay, I'm having trouble with getting my document camera the way I want it, so be a little bit patient with me. Okie dokie. So here we have the same problem, or same type of problem. My common denominator is x plus 5, so I have x squared plus 3x minus 7, and then I have to subtract this whole thing. Which once again means I'm going to distribute negative 1, which in essence changes the sign of everything in there. So this becomes x squared plus 3x minus 7 minus x squared plus 3x plus 1, all divided by x plus 5. Okay, well, anything plus its opposite is 0. 3x plus 3x gives me 6x. Negative 7 plus 1 gives me negative 6 divided by x plus 5. Now I have another twist in this one as well, in that this can be factored. It has a greatest common factor. So this becomes 6 times x minus 1 divided by x plus 5. Okay. This is now a prime factor. This is a factor. This is a factor. So I am done. All right, 29 is the same thing. I've got a common denominator. It's a quadratic, so I'm thinking, well, maybe I'm going to have to factor this later, but let's get there first. Okay, so if I'm adding this is the same thing as adding the opposite of this, which means I'm going to distribute. So this becomes 2x squared plus 8x minus 5 minus x squared minus 6x plus 6, all divided by x squared plus 3x plus 2. Okay, so if I combine my like terms, that gives me x squared plus 2x plus 1 divided by x squared plus 3x plus 2. Okay. Well, now both of these can be factored. In my numerator, I'm looking for two numbers whose product is 1 and sum is 2. They're going to be 1 and 1, so this factors into x plus 1 times x plus 1. Here I'm looking for two numbers that multiply to 2 and add to 3. They're 1 and 2, so I have x plus 1 times x plus 2. I now have a common factor of x plus 1, so my final answer becomes x plus 1 divided by x plus 2. Again, you do not have to do the parentheses. I do it as a reminder of what I'm supposed to do. Okay, whoops, I guess I ought to put the whole parentheses then, huh? Okay. Well, the next two examples do not have like denominators, so the first thing I have to do is find the least common denominator, least common multiple. So, x squared, y squared is x times x, and I'm going to leave some space, times y times y. Xy to the third is x times y times y times y. So my least common denominator is going to be x times y times y times y, which is x to the second, y to the third. Now remember our shortcut for that. You can just look for the highest exponent. The highest exponent of 2 and 1 is 2. The highest exponent of 2 and 3 is 3. But if you do it this way, this will give you some help in figuring out what is missing from each of these. Okay. So here I'm missing a factor of y, and here I'm missing a factor of x. So I'm going to have to multiply each of these terms by something. So 7 over x squared y squared minus 2 over xy to the third. To make sure I have the extra y in here, I have to multiply it by y, which means I have to do the numerator the same. Okay. Here I'm missing a factor of x, so I'm going to have to multiply the denominator by x, which means without changing its value, I have to multiply the numerator by x. So now I have my common denominator of x to the second, y to the third, and my numerator becomes 7y minus 2x. That can't be factored, so there's nothing I can do with that. Okay, on 31, there's not a common denominator, so I have to find one. Whoops. So I know that a plus 7 is it's a prime factor, so it's a plus 7. A minus 2 is also a prime factor, so this is a minus 2. Whoops. So my least common denominator has to have each factor in it. The factor missing here is a minus 2. The factor missing here is a plus 7. So that's what I'm going to have to multiply each of these by in order to get a common denominator. So I have 10 over a plus 7, and I have to multiply it by a minus 2 divided by a minus 2 minus 3 over a minus 2. And I have to multiply it by a plus 7 divided by a plus 7. Now note my denominators are both now the least common denominator. So this becomes 10 times a minus 2 minus 3 times a plus 7 divided by a plus 7 times a minus 2. Okay, from here I'm going to distribute. I'm going to do it twice, making sure I remember to distribute that negative sign. So that gives me 10a minus 20 minus 3a minus 21, all divided by a plus 7 times a minus 2. Okay, so if I have 10a minus 3a, that gives me 7a minus 41, all divided by a plus 7 times a minus 2. Well, they don't have anything in common because 41 and 7 are both prime numbers, so that is my final answer. Okay. All right, find the least common multiple of each pair of polynomials. Okay, we've kind of already done this, but we can always use a little bit of extra practice. Okay, so that means we have to find the prime factorization. Now, there are a couple of shortcuts for this. Okay, if I want to do 18x to the second, y to the second, 18 is 2 times 3 times 3. I'm going to leave some room. Then I have an x and an x. Leave some room. I have a y and a y. 24x to the third y is 2 times 3 times 3 times 2. I'm sorry, times 2. Okay, let me write that over again. I've got plenty of room. So 24x to the third y is equal to 2 times 3 times 2 times 2 times x times y. So my least common multiple has to include a factor of 2, a factor of 3, another factor of 3, a factor of 2, a factor of 2, an x, another x, a y, and another y, which gives me 9 times 8 is 72. Oops, and I forgot 2 x's. Dang it all. So I've got another x in here. And that's going to be x to the third, y to the second. Now remember our shortcut. We can just find the LCM of 18 and 24 and then look for the higher exponent, which is how I knew I made a mistake. The highest exponent for the x, is 2, and for the y is 2. I'm sorry, for the x's is 3 and for the y is 2. Okay, so if I have 8x to the 4th y and 16x to the 2nd y to the 3rd, well, 8 is 2 times 2 times 2. 16 is 2 times 2 times 2 times 2. So for just the numeric part, the LCM has to have 2, 2, 2, and 2. Each column has to be represented. And then for my exponents, my highest exponent for the x's is 4. And for the y's is a 3. So my LCM is 16, x to the 4th, y to the 3rd. Okay, well now if I have factors that are not polynomials that are not monomials, then I've got to factor those and find out what the prime factors are. So 3x to the 2nd plus 6x has the greatest common factor of 3x, and I'm left with x plus 2. 2x plus 4 has a greatest common factor of 2, and then a factor of x plus 2. 2 and 3 are both prime numbers, so I don't have to do anything with that. So the least common multiple has a 2, a 3, an x, and an x plus 2, which is 6x times x plus 2. And I would leave it in that form. You don't have to multiply it out. It's not wrong if you do, but you don't need to. Okay, if I have x to the 4th minus 4 and x to the 2nd plus 2x, x to the 2nd minus 4 is a perfect square, a difference of squares, so this factors into x plus 2 times x minus 2. X squared plus 2x has a greatest common factor of x, and then the remaining factor is x plus 2. So my least common multiple is x times x plus 2 times x minus 2. And again, you can leave it just like that. That is your least common multiple. Okay, let's stop here and then we'll go on to solving on the next video.